Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the turning points using completing the square practice questions. So in this video, we're going to look at the video solutions to the practice questions. If you do need any extra help on finding the coordinates of turning points using completing the square, I highly recommend you go to corbettmaths.com and you go to the contents page or the videos and worksheets page, and you scroll down to video number 265A. And there's a video tutorial on how to find the coordinates of turning points using completing the square. Alternatively, scan this QR code and it'll bring you straight to it. But in this video, we're going to look at the video solutions to the practice questions, so let's get started. So our first question says, question 1a, write x squared plus 4x minus 6 in the form of x plus a, close bracket squared, subtract b. So in this video, I'm going to assume that you know how to do completing the square. If you're not confident on completing the square, you really need to go and watch that video first of all. Okay, so we've got x squared plus 4x minus 6. So we need to write it in this form, so we need to do completing the square. So we're going to open up our brackets, we're going to put our x, then we're going to half the coefficient of x, so we're going to half this 4, so that's 2, so plus 2, and then do close brackets squared. Then we're going to take away whatever number this is squared, so we're going to take away 2 squared. 2 squared is 4, so we're going to write take away 4, and then we've still got our take away 6, so then put take away 6 on the end. And then whenever we simplify this, we've got our x plus 2, close bracket squared, and then minus 4, take away 6 would be minus 10. So then we would have it in the form of brackets x plus 2, close bracket squared, take away 10. And that's in the form that we were asked to get it in the question. So we've done completing the square. Okay, then if we have a look at part B says sketch the graph of y equals x squared plus 4x take away 6 and show the coordinates of the turning point and the y-intercept. So first of all, we've written this quadratic in this form. We've done completing the square, so let's write that out. Y equals, and instead of x squared plus 4x minus 6, we can write x plus 2, close bracket squared, take away 10. And we're going to sketch that graph. So if we go down to our axes, so first of all, what I'm going to do is I'm going to consider the graph of y equals x squared. So y equals x squared would look something like this. So that's my sketch of y equals x squared. Now, it's not the best sketch, but it's the best I can do on the computer here. So we've got y equals x squared looks something like that. Now, we want to sketch the graph of y equals x plus 2, close bracket squared, take away 10. So we're going to need to know our transformations of graphs. So we've got plus 2 inside the brackets. Now, instead of moving the graph 2 squares to the right, that would move the graph 2 squares to the left. It's counterintuitive. So using that x plus 2, we can actually move the graph 2 squares to the left. So it would look something like that. And that would be the point, instead of being the origin, this would be the point now at negative 2. And then we then have minus 10. That means we're going to translate the graph 10 squares downwards. So we would move the graph 10 squares downwards, so it would look something like this. And then we can just label our points. So this point here would be the point negative 2, because it's negative 2 across, and we've gone 10 down. So negative 2, negative 10. So that's the coordinates of the turning point, this turning point here. And then the question, we're also asked to write down the y-intercept. So let's look at our graph. We want to find where it crosses the y-axis. Now, to find where a quadratic or any graph crosses the y-axis, we substitute in x equals 0. So if we go back up to our equation, our y equals x squared plus 4x minus 6, and we let x equal 0, we'd have y equals x squared plus 4x minus 6. And if we let x equal 0, we would get y equals 0 squared plus 4 times 0, subtract 6. 0 squared is 0. 4 times 0 is 0, so plus 0, and then we've got our take away 6. So that means that we'd have 0 plus 0 take away 6, that's going to be equal to negative 6. So that means that our y-intercept is the point 0, negative 6. So our y-intercept is negative 6. And that's it. So that is our graph, that is our sketch of our graph. We start off with the x squared graph, and using our knowledge of completing the square, we knew we were going to translate it 2 squares to the left, and then 10 squares down. So we start off with the quadratic graph, we moved it 2 squares to the left, 10 squares down, and it would look something like this. And to find the y-intercept, or the coordinates where across the y-axis, what I would do is I would substitute in x equals 0 into the equation of the quadratic, so either here or here. And either one, if you substitute in x equals 0, you would get negative 6. And that's it. Okay, so our next question, question 2a, says write x squared subtract 2x plus 10 in the form of x minus a, close bracket squared, plus b. In other words, we need to do completing the square. So let's open up our brackets, put x. We're going to half the coefficient of x. The coefficient of x, the number in front of the x is negative 2. When we half that, we get negative 1. So we've got x minus 1, close bracket squared. We're now going to take away whatever we get when we square this number. Negative 1 times negative 1 is 1. So we're going to do right then minus 1. And then we've still got our plus 10, so plus 10. And then we just need to simplify this. So we've got x minus 1, close bracket squared. And then we've got negative 1 plus 10. That's going to be 9, so plus 9. So in this form, it would be x minus 1, close bracket squared, plus 9. Okay, and part B. Part B says sketch the graph of y equals x squared minus 2x plus 10 and show the coordinates of the turning point and the y-intercept. So we want to sketch this graph. Now we know that it's y equals x squared minus 2x plus 10, but we wrote that in this form. So we've got y equals x minus 1 close bracket squared plus 9. So if we go down to our axes, let's sketch our y equals x squared graph to begin with. So it would look something like this. And that's my sketch of y equals x squared. Now if we have a look at what we've got here, we've got x minus 1 in brackets. That means we're going to translate the graph 1 squared to the right. So with subtract 1 inside the bracket, you would think it would move 1 to the left, but it's counterintuitive, it moves 1 to the right. So our graph of y equals x squared would move to here. So it would now touch here at 1. And then we've got plus 9. That means we translate the graph 9 squares upwards. So it's going to move up 9 squares to somewhere like that. And then that means that the turning point, the coordinates of this turning point would be 1, 9, because we've translated the graph 1 square to the right and 9 squares up. So the coordinates of the turning point are 1, 9. Now let's find the y-intercept. So to find the y-intercept, remember x equals 0, and we can substitute in x equals 0 into either here or here. I'm going to choose what they've given me in the question. So I'm going to let x equal 0, so y equals x squared, so 0 squared, minus 2 times 0, so 2 times 0 is 0, so minus 0, plus 10. So we then get 0 squared minus 0 plus 10, so y equals 10. So that means that it crosses the y-axis at 10, so the coordinates of this y-intercept would be 0, 10. And that's it. So the coordinates of the turning point would be 1, 9, the coordinates of the y-intercept would be 0, 10, and the graph would look something like this, where the x squared graph was translated 1 square to the right and 9 squares up. Okay, let's have a look at our next question. So question 3. Question 3 says the equation of a curve is y equals x minus 3 close bracket squared plus 4. So we've got a quadratic, and actually it's quite nice in this question because the completing the square has been done for us, and we've been asked to write down the coordinates of the turning point. So remember, if we had our x and y axis, or x and y axis, and we had a quadratic graph, it would look something like that. So we've got minus 3 inside the brackets. So I would translate the graph 3 squares to the right. So it would now be here, where that would be 3 on the x-axis. And then we've got plus 4, so that's going to translate the graph 4 squares upwards. So it would go up to here. So the coordinates of the turning point would be here, which are 3, because we're going 3 to the right, and then 4 up, so 3, 4. So the coordinates of the turning point would be 3, 4. And that's it. Okay, let's have a look at our next one. So our next one, we've got the equation of a curve is y equals x plus 6, close bracket squared, subtract 8. So again, it's quite nice. Completing the square has been done for us. And we've been asked to write down the coordinates of the turning point. So if we had the sketch of y equals x squared, it would look something like this, where it touches the origin and goes back up. Now if we have a look at this, we've got x plus 6. So we've got plus 6 inside the brackets. So using our knowledge of transforming graphs, adding 6 inside the brackets moves the graph, or translates the graph 6 squares to the left. So it goes this way. So now that would be negative 6 there. And then we've got minus 8, so that's going to translate the graph 8 squares downwards, so it would move down to here somewhere. And then that means the coordinates of this turning point here would be negative 6, because it's gone 6 squares to the left. And then we've got 8 squares down, so negative 8. So the coordinates of this turning point here would be negative 6, negative 8. And that's it. Okay, let's have a look at question 5. So question number 5 says the equation of a curve is y equals x minus 1 close bracket squared plus 13. I've been asked to write down the coordinates of the turning point. So looking at this, I can see we're translating the graph 1 square to the right and 13 squares up. So I know it's going to be 1, 13. But again, let's do our sketch and see what we get. So I've just sketched our y equals x squared graph, so something like this. And we've got our x minus 1, so we've got minus 1 inside the bracket. So instead of moving the graph 1 square to the left, remember it's counterintuitive, it moves the graph 1 square to the right. So it now touches here at 1. And then we've got plus 13, so that means it's going to translate the graph 13 squares up, so it would go to somewhere like that. And that means the coordinates of that turning point there would be 1, 13. And that's it. So our answer is 1, 13. The coordinates of the turning point, or the minimum point, is 1, 13. Okay, let's have a look at our next one. So question 6 says the equation of a curve is y equals x plus 7 close bracket squared. Write down the coordinates of the turning point. So again, let's do our sketch. So we've got our x and y axis, and there's our sketch of y equals x squared. Now here you can see we've got x plus 7, so we've got plus 7 inside the brackets. That's going to translate the graph 7 squares to the left. So it's going to move over here. So then that would now be, it would now touch at negative 7 there on the x-axis. And then it goes back up. Now we don't have a plus or a minus here, so the graph actually will just stay there. So that will be our graph of y equals x plus 7 close bracket squared. I've been asked to write down the coordinates of the turning point. So remember, we've gone 7 squares to the left. We haven't gone up or down. So the coordinates of that turning point would be negative 7, 0. And that's it. Okay, let's have a look at question number 7. So question number 7a says, write x squared plus 8x plus 18 in the form of x plus a close bracket squared plus b. So we're going to be doing completing the square on this, so that's going to be x plus, and then we've got half of 8, which would be 4, so x plus 4 close bracket squared. We're going to take away whatever this number is squared, so 4 squared is 16, so take away 16, and then we've got plus 18, so we put plus 18 on the end. And then that means that we would have x plus 4 close bracket squared, and we've got negative 16 plus 18, so it's going to be 2, because negative 16 plus 18 is 2, so plus 2. So in the form of x plus a close bracket squared plus b would be x plus 4 close bracket squared plus 2. Okay, and part B says, hence write down the coordinates of the turning point of y equals x squared plus 8x plus 18. So we've got a y in front of this, so that means that we would have y equals, and because we've written x squared plus 8x plus 18 in this form, we can then write it here, y equals x plus 4 close bracket squared plus 2. So we've done completing the square. Now we just need to consider where the turning point will be. So let's sketch our x and y axis, or our x axis and our y axis. Our y equals x squared graph would look something like this. Now if we have a look, we've got plus 4 inside the brackets, so that translates the graph 4 squares to the left. So it now touches the x axis here at negative 4, so that's a negative 4. And then we've got plus 2, so that translates the graph 2 squares upwards, so it goes up to here. So that means that the coordinates of this minimum point, of this turning point here, would be negative 4, 2. So the coordinates of the turning point would be negative 4, 2. And that's it. Okay, let's have a look at our next question. So if we have a look at question 8, it's quite similar to question 7. We've been given that x squared minus 10x plus 3 is equivalent to x minus a close bracket squared minus b. So that just means we need to do completing the square to this, and we can then get what this is. And then in part B, we need to find the coordinates of the turning point. So let's do completing the square on our x squared minus 10x plus 3. So that would be, open up brackets, x, half of minus 10 would be minus 5, close bracket squared, then subtract, and minus 5 squared is 25, so we're going to take away 25, and then we've still got our plus 3, so plus 3. And then simplifying, we'd get x minus 5, close bracket squared, and minus 25 plus 3, we're going to go back up towards 0, so it's going to be minus 22. And that's it. So we've written it in this form because we had x minus a, so we've got x minus 5, so that means that a is 5, we're taking away 5. And then we've got minus b, well, we're minusing 22, so we're taking away 22. So a is 5 and b is 22, so we've got x minus 5, close bracket squared, minus 22. Okay, let's have a look at our next part. Part B says, hence write down the coordinates of the turning point to this. So we've got, instead of our x squared minus 10x plus 3, we've got y equals x squared minus 10x plus 3. So we now know that that's y equals, and then open up brackets, x minus 5, close bracket squared, minus 22, what we found in part A. And we can use that knowledge to find the coordinates of the turning point. So remember, do our sketch, our x and y axis. And because we've got x minus 5, we've got minus 5 in the bracket, we're going to translate the graph 5 squares to the right. So it's now going to touch here at 5. And then we've got minus 22, so the graph's going to be translated 22 downwards. So go down to there, and then the coordinates of this turning point here would be 5, because we're going 5 across, and 22 down, so 5 minus 22. So the coordinates of the turning point would be 5 minus 22, and that's it. So question number 9. Question number 9 says, a curve has got equation y equals x squared minus 16x plus 45, and we're to use completing the square to work out the coordinates of the turning point. So let's do completing the square on this. So we'd have y equals, then open brackets, x, and then we've got half of minus 16, so minus 8, close brackets squared, and then take away, and minus 8 squared is 64, so take away 64, and then we've still got our plus 45, so plus 45. So that'd be y equals, and then x minus 8, close bracket squared, and then minus 64 plus 45 is minus 19, so minus 19. So we've written our y equals, and then our quadratic in the form of y equals, and then we've done completing the square. Now we're going to do our sketch, so let's have our x and y axis, so x axis and y axis. And the quadratic graph would look something like this. And then inside the bracket, we've got minus 8. That means we're going to translate the graph 8 squares to the right. So it's going to go 8 to the right. So that's going to be 8 on the x-axis there. And then we've got minus 19. So we're going to translate the graph 19 squares downwards. So it's going to move down to there somewhere. And that means the coordinates of this turning point would be, well, we've got an 8 to the right, so 8. And then we've got 19 down, so minus 19. So the coordinates of the turning point would be 8, negative 19. And that's it. Okay, let's have a look at our next question, question number 10. So question number 10 said, a curve has got equation y equals x squared plus 12x plus 80, and use completing the square, work out the coordinates of the turning point. So let's again do completing the square. So we've got y equals, and then open up brackets, x, half of 12 is 6, so plus 6, close bracket squared. We're going to take away what this is squared, so 6 squared is 36, so minus 36, and then we've got plus 80. Now minus 36 plus 80 would be 44, so we're going to have y equals x plus 6, close bracket squared, and then we've got plus 44. Now we're just going to sketch our x and y axis. We've got our x axis and our y axis, and we're going to do our sketch of y equals x squared. So that's our sketch of y equals x squared. It's a bit steeper this time. And then we've got x plus 6, so that's going to translate the graph 6 squares to the left, so we're going to go to here. And then let's again label on our minus 6 there. And then we've got plus 44, so it's going to translate the graph 44 upwards. So it's going to move up to here, or it might even move up to here somewhere, but we'll move it up to here. And then that means that the coordinate of this minimum point here, this turning point, would be negative 6, 44. And so the coordinates of the turning point would be negative 6, 44. Okay, let's have a look at question number 11. So question number 11 says y equals x squared minus 6x minus 17, and we'll work out the coordinates of the turning point. So again, let's do completing the square, y equals, and then we've got x, and then half of minus 6 would be minus 3, close bracket squared. We're going to take away this squared, so minus 3 squared is 9, so take away 9, and then we've got minus 17. So it's going to be y equals, and then x minus 3, close bracket squared, and then minus 9, take away 17 would be minus 26. Now we've done completing the square, we can just consider our sketch. So we've got our x and our y axis. We've got our graph of y equals x squared, and we're going to translate the graph 3 squares to the right, because it says minus 3 inside the bracket. We're going to translate 3 squares to the right at 3, and then 26 downwards, so that we're going to go down 26, so down to here somewhere, down to about here somewhere. So that means the coordinates of this turning point here, this minimum point would be 3, and then minus 26, or negative 26. So it'd be 3, negative 26. So it would be 3, negative 26. And that's it. Okay, let's have a look at our next question. So question number 12. Question number 12 says a curve has got equation y equals x squared plus 4x plus 1. And we've been asked to work out the coordinates of the turning point. So y equals, and we'll do completing this square. So x, and half of 4 is 2, so plus 2, close bracket squared. We take away this number squared, 2 squared is 4, so take away 4, and then we've still got our plus 1. So that is going to be y equals x plus 2, close bracket squared. Now we had minus 4 plus 1, so going back up 1 will be minus 3. Then we've got our x and our y axis, so our x axis and y axis, and we're going to sketch the graph of y equals x squared and consider our transformations of graphs. So that's my sketch of y equals x squared. Inside the bracket we've got plus 2, so it's going to translate the graph 2 squares to the left. So it's going to be there. So that will now be negative 2 on the x-axis. And then we've got minus 3, so that translates the graph 3 downwards. So that means the coordinates of this minimum point here would be negative 2, negative 3. And that's it. So the coordinates of the turning point would be negative 2, negative 3. Okay, part B. Part B says write down the equation of the line of symmetry of y equals x squared plus 4x plus 1. So because this is a quadratic graph or parabola, it's got a line of symmetry. And the line of symmetry will be a vertical line that passes straight through that turning point. So it's going to be a vertical line like so that passes straight through that turning point. And the turning point was the point with the coordinates negative 2, negative 3. So it's going to be a vertical line that goes straight through negative 2 on the x-axis. Now that line will have an equation, because it's a vertical line, it'll be in the form x equals, because all of them have the same x coordinate, and it passes through negative 2 on the x-axis, so the equation of that line of symmetry would be x equals negative 2. And that's it. So if you know the coordinates of the turning point, you can easily find the equation of the line of symmetry, because you know it's just going to be x equals and whatever the x coordinate would be. So if this turning point had coordinates 10, 1, the equation of the line of symmetry would be x equals 10, and so on. Okay, let's have a look at the next part. So the next part says a straight line y equals 3x plus 1. So it's a straight line y equals 3x plus 1. So it's going to be a line that looks something like that. It intersects the curve y equals x squared plus 4x plus 1. So that's the curve we've been given in the question at the points A and B. And we've been asked to find the coordinates of those points A and B. And if we were to draw the graph of y equals 3x plus 1, it would look something like this. So it'll be a diagonal line, and it crosses or meets the quadratic graph, this parabola, twice at the points A and at the points B. So here at A and over here somewhere at B. And we've been asked to work out those coordinates. Now what's quite nice about this question is we've got y equals something and y equals something. So if we want to find where they meet each other, we can just put them equal to each other. So we can write 3x plus 1 equals x squared plus 4x plus 1. And if we solve this, we can then find the coordinates of a and b. So let's see what we'd get. So we want to get this equal to 0. So whenever we're solving a quadratic, we'd like the quadratic to equal 0. So let's make the left-hand side of this equation 0. So let's take away 3x and take away 3x. And when we do that, on the left-hand side, we have 3x plus 1. We're going to take away the 3x, that will just leave us with 1. And on the right-hand side, we had x squared plus 4x plus 1. When we take away 3x's, that will leave us with x squared plus 1x, or plus x plus 1. Now we want this to equal 0, so we're going to take away 1 from both sides of this equation. 1 take away 1 is 0. And on the right hand side, we're going to be left with, we've got our x squared plus x. We had 1, we took it away. Well, that's equal to 0 as well. So we've got 0 equals x squared plus 1. Now to solve this quadratic, what we're going to do is we're going to factorize this right hand side. So we've got 0 equals. Now here we've got x squared plus x. So if we take x out, that would leave us with x bracket x plus 1, factorizing this. Now for this to be equal to 0, either x is going to be 0 or x plus 1 is equal to 0. So that means either x equals 0 or, and if this is equal to 0, x plus 1 is equal to 0, that means that x would be equal to negative 1, because negative 1 plus 1 is 0. So that means that either x is equal to 0 or x is equal to negative 1. So we've got our x coordinates, so we now just need to find our y coordinates. So we can substitute this 0 and negative 1 either into the quadratic, if you wanted to, or into this straight line. And that's what I'm going to do. I'm going to substitute both of these values, x equals 0 and x equals negative 1, into here to find the y coordinates. So whenever x equals 0, we've got y equals 3x plus 1. So whenever x equals to 0, we get y equals 3 times 0, so that's 0, plus 1, so plus 1. So y equals 1. So that would be the coordinate 0, 1. Because whenever x equals to 0, y is equal to 1. So that's one of our coordinates. And the other coordinate, we know that x is equal to negative 1. So whenever we substitute that into y equals 3x plus 1, we know that x is equal to negative 1. So we get y equals 3 times negative 1. That's going to be negative 3 plus 1. And negative 3 plus 1, well, at negative 3, go back up 1, that's going to be negative 2. So y equals negative 2. So whenever x is equal to negative 1, y is equal to negative 2. So that would be the coordinates negative 1, negative 2. And we were asked to write down the coordinates of a and b. So I'm going to write a is equal to this one, because the first one to the left. So a is equal to negative 1, negative 2, and b is equal to the point 0, 1. And that's it. So they're the coordinates where the quadratic met the straight line. And that's it. Okay, let's have a look at our next question. Okay, question number 13a. So question number 13a says, sketch the graph of y equals x squared minus 14x plus 52 and show the coordinates of any turning points. So let's do completing the square. So we're going to have y equals, and then open brackets, x, and half of minus 14 would be minus 7, close bracket squared. We're going to take away that squared. Well, minus 7 squared is 49, so take away 49 plus 52, so plus 52. And then we've got y equals, so then x minus 7, close bracket squared, and then minus 49 plus 52 is 3, so plus 3. Now we want to sketch this, so let's start off by sketching our y equals x squared, and we're going to translate the graph 7 squares to the right, because we've got minus 7 inside the bracket, so 7 squares to the right, so that's now going to be there, and let's call that then 7 on the x-axis. And then 3 squares up, so it translates the graph 3 squares upwards, so it would look something like that. So that means that the coordinates of the turning point would be here, which would be 7, 3. Okay, part B. So let's have a look at part B. So part B says, here's a sketch of a curve of equation y equals x squared plus ax plus b. So this is a quadratic graph, and it crosses the x-axis at negative 8 and 2. And we've been asked to find the coordinates of the turning point of the curve. So we want to find the coordinates of this point here. Now remember, to find out what quadratic graph crosses the x-axis, you would normally factorize it if you can and put it equal to 0. And then you could figure out the answers, knowing that either one bracket or the other bracket equals 0, and then you could figure out what then the values of x would be. And in this case, we would have got negative 8 and 2. So that means we would have had in our brackets x plus 8, and in the other bracket would be x minus 2. Because if we were to put this equal to 0, we would get x plus 8 times x minus 2 equals 0. So that means that either x would be equal to negative 8 or x is equal to 2. So that means the equation of this quadratic, because we know it's an x squared quadratic, would be y equals x plus 8 times x minus 2. Now in this question, we've been asked to find the coordinates of the turning point, so we want the coordinates of the turning point here. Now there's two different ways we can do this. One approach is we could expand this to get y equals, and if we expanded these brackets, we would get x times x is x squared, x times minus 2 would be minus 2x, 8 times 2 would be plus 8x, and 8 times negative 2 would be minus 16, and then that would simplify to be y equals x squared, and then we've got minus 2 plus 8, so it's going to be plus 6x, and then we've got take away 16. So that means the equation of this quadratic would be y equals x squared plus 6x minus 16. And one approach to get the coordinates of this turning point would be now to do completing the square, so that would be y equals, and then x, and then half of this number would be plus 3, close bracket squared, take away 3 squared, which is 9, and then minus 16. And then that would give us y equals x plus 3, close bracket squared, minus 9, take away 16 would be minus 25. And now we can use this information to figure out the coordinates of this turning point, because if we had the quadratic graph, we would translate it 3 squares to the left, so 3 squares to the left would be there to negative 3, and then 25 down would bring it to here, so this would be the point negative 3, negative 25. So that means the coordinates to this point would be negative 3, negative 25. So that's one way to find the coordinates of that turning point there. Another approach would be, rather than expanding the brackets, we could have actually done this question a slightly different way. If we had y equals x plus 8, x minus 2, because we know that the parabola has got a line of symmetry, we could find the midpoint of negative 8 and 2. And to find the midpoint of negative 8 and 2, well, remember, to find the midpoint of two numbers, we add them together and half it. So negative 8 plus 2 would be equal to negative 6, and half it is negative 3. So we know straight away that the coordinate has got an x-coordinate of negative 3, because it's going to be in the middle of these 2 points, because it's got a line of symmetry. So we knew it would have to be negative 3. And to get the y-coordinate, what we can then do is, because we know that x is equal to negative 3, we can substitute that into this. So in for the values of x here and x here, and then we can figure out what y is. So we know that y would be equal to negative 3 plus 8. So negative 3 plus 8 would be 5. And then multiply by it. And here we'd have negative 3 take away 2. Well, negative 3 take away 2 is negative 5. We've got 5 times minus 5, which would be minus 25. So that will be minus 3 minus 25. And that's it. So the coordinates of this turning point would be negative 3, negative 25. Okay, let's have a look at our next question. Okay, let's have a look at question number 14. So question number 14 says the point negative 3, 8 is the turning point of the graph y equals x squared plus ax plus b, where a and b are integers. Find the values of a and b. Now what's quite nice here is that we've got the coordinates of the turning point, and we know it's an x squared graph, so we don't need to worry about 2x squareds and so on in this question. So we've got the coordinates of the turning point, so we know if we sketch this quadratic, we had this quadratic, it would look something like this. So the turning point is negative 3, 8, so the turning point is here, and it would look something like this. So it would go through negative 3, 8. So that's what the quadratic would look like, because we know it's an x squared parabola, so it's going to be a u-shaped one, and it has a turning point of negative 3, 8, so it's going to look something like this. Now if we think about it, we start off with y equals x squared, so if we had y equals x squared, we've translated it 3 squares to the left, so that means that inside of our brackets we would have x plus 3, because we've translated it 3 to the left. So remember, inside the brackets is counterintuitive. Close bracket squared, and then the curve's been translated 8 squares upwards, so then it would be plus 8. So we would have y equals x plus 3, close bracket squared, plus 8, because it's going to translate it 3 squares to the left and 8 squares up. Now if we expand this and simplify it, we can get our values for a and b. So that would be y equals x plus 3 multiplied by itself, x plus 3, close brackets, plus 8, and then that would be expanding, x times x is x squared, and x times 3 is 3x, and 3 times x is 3x, adding them together would be 6x, and then 3 times 3 is plus 9, and then we've still got our plus 8. Now we just need to simplify, so that would be y equals, and we've got x squared, we've got our plus 6x, and then we've got 9 plus 8 would be equal to 17. So that means the value for a would be 6, and the value for b would be 17. So let's write that down. A is 6, and b is 17. And that's it. Okay, let's have a look at question number 15. So question number 15 says the point 5, negative 1 is the turning point of the graph y equals x squared. That's nice because it's just x squared and x squared, so it's a u-shaped parabola. Y equals x squared plus ax plus b, where a and b are integers. Find the values of a and b. So again, let's sketch our axes, x-axis and y-axis. And we know the turning point is 5, negative 1. So the turning point's here somewhere. So it's going to be a parabola that looks something like this. And we need to find the values of a and b. So if we were to consider our y equals x squared parabola, it's been translated 5 squares to the right and 1 square down. So we're going to do y equals, and then we've got x. Now we want to translate 5 squares to the right, so it's going to then be minus 5, because remember it's counterintuitive. If you take away 5 inside the brackets, it translates it 5 squares to the right, close bracket squared. And then we'll translate it at 1 square down, so then it'll be subtract 1. So that means if we expand this, we would get y equals x minus 5, x minus 5. minus 1. And then expand on our brackets, x times x is x squared. X times a negative 5 is negative 5x, and negative 5 times x is negative 5x. Adding them together would be negative 10x. And then negative 5 times negative 5 would be plus 25. And then we've still got our minus 1. And then finally, 25 take away 1 is 24, so we'd have y equals x squared minus 10x plus 24. And that means the value for a would be negative 10, and the value for b would be 24. And let's write that down. A is negative 10, and b is 24. Okay, let's have a look at our next question. Okay, let's have a look at question number 16. So question number 16 says a curve is equation y equals x squared plus 5x plus 7. And we're to use completing the square to work out the coordinates of the turning point. So it's an x squared parabola, so it's going to be a U-shaped parabola. And this question is a bit different than the others because we've got an odd coefficient of x. All the questions so far have had, 4x or minus 6x and things we can half nicely. In this question, I'm just going to show you that you can do it for odd numbers as well. So we're going to be doing y equals, and we're going to do completing the square on this. So it's going to be x plus, and half of 5 would be, well, 5 divided by 2 would be 5 over 2. That would be half of the coefficient of x. Close bracket squared. Now we're going to take away this number squared. So 5 over 2 multiply by itself, 5 over 2. 5 times 5 is 25, and 2 times 2 is equal to 4. So take away that number squared, which would be take away 25 over 4, and then we've still got our plus 7, so plus 7. Now we need to simplify this, so we've got y equals x plus 5 over 2, close bracket squared, and then we've got minus 25 over 4 plus 7. Now 7, if we write it as a fraction with a denominator of 4, that would be better. So we've got 7 over 1, we want that to be equal to something over 4. So to get from 1 to 4, we times by 4, so that'll be equal to 7 times 4 would be equal to 28. So that means that 7 is equal to 28 quarters. So that means we've got minus 25 over 4 plus, and instead of 7, we're going to write that equal to 28 quarters. 28 quarters. Then we've got y equals x plus 5 over 2, close bracket squared. Then we've got minus 25 quarters plus 28 quarters. That's going to leave us with 3 quarters, so plus 3 quarters. And now we just need to find the coordinates of the turning point. So let's consider our graph. So we'd have our x and y axis, x and y. And if we start off with our y equals x squared graph, we've got x plus 5 over 2. That means we're going to translate the graph 5 over 2 to the left. Remember, we're adding inside the bracket, so we're going to translate it to the left. So that's going to be minus 5 over 2. And then we're going to move the graph 3 quarters up. So we're going to then translate it 3 quarters upwards. It's going to move to there. So that means that the coordinates of this turning point would be minus 5 over 2, 3 quarters. And that's it. So the coordinates of the turning point would be minus 5 over 2, 3 quarters. And that's it. Okay, let's have a look at question number 17. So question number 17 said a curve has got equation y equals minus x squared minus 4x plus 22. And we've been asked to work out the coordinates of the turning point. Now this quadratic is a minus x squared quadratic, so rather than being a U-shaped parabola, it's going to be an N-shaped parabola. So it means that we're going to be finding the coordinates of the maximum point rather than all the minimum points we've done so far. Now whenever I'm doing a question like this, because completing the square can be a wee bit trickier whenever you've got this minus x squared and so on, what I tend to do is actually consider if the graph was like this. So here we've got our N-shaped parabola. This could be y equals minus x squared minus 4x plus 22. That might not be this. It might actually be over here somewhere. I don't know necessarily what the graph looks like so far. But if it was here, for instance, and I wanted to find the coordinates of this maximum point here, what I actually do is I look at this graph here, this U-shaped parabola. So what I actually do is I find the reflection of the graph we've been given in the x-axis, and I find the coordinates of that minimum point. Once I find the coordinates at that minimum point, then I can find the coordinates of this maximum point quite easily. So for instance, if this point was minus 5 across and 8 down, I know this point would be minus 5 across and 8 up. And that means I can find the coordinate of the maximum point. So what I'm actually going to do is, rather than focusing on this N-shaped parabola, I'm actually going to consider this U-shaped parabola the reflection of the graph we've been given in the x-axis. So if, for instance, what we've been given is f of x, so f of x is equal to minus x squared minus 4x plus 22. Whenever you reflect that in the x-axis, that would be y equals minus f of x. So that's what you get whenever you multiply all of this by negative 1, or you change all the signs. So that'll be x squared plus 4x minus 22. And what I'm going to do is I'm going to find the coordinates of the minimum point of this quadratic. So this y equals x squared plus 4x minus 22. And whenever I find the coordinates of that minimum point, then I can then find out what the coordinates of this maximum point would be. So for y equals x squared plus 4x minus 22, that would be y equals, and then do completing the square, x plus 2, close bracket, squared, minus, and then 2 squared is 4, minus 22. So it'd be y equals x plus 2, close bracket, squared, and then minus 4, take away 22 would be minus 26. So that means that if I had the y equals x squared, I would translate it 2 squares to the left, so it goes somewhere like that, and then 26 squares down, so 26 down would look something like that. So that means this quadratic would have a turning point here of minus 2 minus 26, because it was translated 2 squares to the left and 26 squares down. Now this isn't y equals minus x squared minus 4x plus 22, it's the reflection of that graph in the x-axis. So if we were to reflect this U-shaped parabola in the x-axis, that would have been our y equals minus x squared minus 4x plus 22. So that means the turning point here, the maximum point would be minus 2, because we've gone 2 to the left, and 26 up, so minus 2, 26. So the coordinates of the maximum point of this N-shaped parabola would be minus 2, 26. So minus 2, 26. And that's it. So in this question, rather than finding the turning point of the N-shaped parabola, I reflected it in the x-axis, and then I found the minimum point of that U-shaped parabola, and then I reflected it back, and then I figured out what the turning point of that N-shaped parabola would be. Okay, let's have a look at question number 18. So question number 18 says the turning point of the curve of equation y equals x squared minus 8x plus b has a y coordinate of 14. Find the value of b. So here we normally know this value for b here, and we can do completing the square to find the coordinates of the turning point. What I'm actually going to do is I'm going to do completing the square for what we've been given. So we've got y equals, and then we've got open brackets x. We're going to half the coefficient of 8, so half of minus 8 would be minus 4, close bracket, squared. We would then take away whatever this value is squared, so minus 4 squared is 16, so we're going to take away 16, and then we would add on or take away whatever value is here, so we're going to add on b. And then normally what we would do is we could draw our y equals x squared quadratic, this, and we would look at what we've got here, and we'd go x minus 4, so that says translate the graph 4 squares to the right. And then we would look at this bit to see if we would move it up or down. Now we don't know what the value for b is here, so we don't know if we're going up or down, but if we look at the question, it says it's got a y coordinate of 14. The turning point has a y coordinate of 14. So that means it's going to go up 14. So that means this must have been plus 14, because this says translate the graph 4 squares to the right, and then this bit must have said plus 14, because we're going to translate it 14 squares upwards. So that means that minus 16 plus b is equal to 14. And if we solve this, we won't want to find out what b is, so we're going to add 16 to both sides, so add 16 and add 16, and that gives us b is equal to 30. So that means that b must have been equal to 30, and that's it. Okay, let's have a look at question number 19. Okay, question number 19 says the curve of equation y equals x plus a close bracket squared plus b passes through the point 2, 4. So that's the point where it passes through 2, 4, where the x value is 2 and the y value is 4. And then we're told the turning point of the curve has an x coordinate of minus 1. So normally we consider our y equals x squared quadratic, and this has been translated 1 square to the left. So that means that here this must be y equals, and then in brackets, x plus 1, close bracket, squared, because that would translate the graph 1 squared to the left, and that would give the turning point in the x coordinate of minus 1. And then we would have r plus b. And the question says find the y coordinate of the turning point. So really what we need to do is we need to figure out what b is, because if we can figure out what b is, that would tell us we would translate 1 square to the left, and b would then either move the quadratic graph upwards or downwards, and whatever the value for b is would be how much up or down, and that would be the y coordinate of the turning point. So really what we need to do is find out what b is. So we've got y equals x plus 1 close bracket squared plus b. Now we know that the quadratic passes through the point 2, 4. So we know that x here would be equal to 2 and y is equal to 4. So if we substitute those into our equation, we can then hopefully find our b. So y, which is equal to 4, so 4 is equal to x plus 1, so that's 2 plus 1, so that's going to be 3 squared plus b. 3 squared is equal to 9, so 4 equals 9 plus b. Take away 9 from both sides, 4 take away 9 is minus 5, so we get minus 5 is equal to b. So b is equal to minus 5. So that means that we have y equals x plus 1 close bracket squared minus 5. That says translate the graph 1 square to the left and 5 downwards. So the y coordinate of the turning point would be minus 5. So that's it, so minus 5. So question number 20 says sketch the graph of y equals 2x squared minus 12x plus 1, and we're to show the coordinates of the turning point and the coordinates of any intersection points with the coordinate axes, or any intercepts with the coordinate axes. So we've got our y equals 2x squared minus 12x plus 1, and let's find the coordinate of the turning point to begin with. So let's do completing the square on this. So we're going to have y equals, now we've got 2x squared, so what I'm actually going to do is I'm going to take 2 out to begin with. So I'm going to do 2 and then a square bracket, and then if that would leave me with, if I divide all this by 2, it would be x squared minus 6x and then plus a half. Okay, so just taking the 2 out. Now I can do completing the square nicely in here. So that'd be y equals, and then 2, square bracket, and then a smaller bracket, and then x minus, and half of this number, half of minus 6 would be minus 3, close bracket, squared. And then we take away whatever that is squared. Minus 3 times minus 3 is 9, so take away 9. And then we've got plus a half, so plus a half. And then our square brackets. And then that'll be y equals 2, open up our big brackets, and then we've got x minus 3, close bracket, squared. And then we've got minus 9 plus a half. So minus 9 plus a half would be minus 8.5. We could write that as minus 8.5 or 8.5, minus 8.5, or I'm going to actually write it as minus 17 over 2. Because 17 over 2 is 8.5, so minus 8.5, and then our square brackets. And then what I'm going to do is I'm going to expand here, so 2 times this would be 2 bracket x minus 3 close bracket squared. And then we've got 2 times minus 17 over 2. Well, that's going to be minus 17, because remember 2 times minus 8.5 would be minus 17, so minus 17. Okay, so we've done our completing the square. Now let's consider where the graph will go to. So if we consider our y equals x squared graph to begin with, our y equals x squared graph would look something like this. So to start off with, we're going to look at our bracket. We've got x minus 3, so that would translate the graph 3 squares to the right. Because it's minus 3, we translate to the right. And I'm actually just going to label here the point 3 on the x-axis. And then we've got our 2 here. That would double the heights of all the coordinates. So the graph would now look something like this, where all the points were twice the height. So if this had a height of 1, it would now have a height of 2, and so on. Now the point on the x-axis would stay where it is. So it would look something like that. Let's get rid of our original one. And then finally, we've then got take away 17. So that's going to move the graph 17 downwards. So it looks something like this. And so that means the coordinates of the turning point of that quadratic would be 3, negative 17. And then in the question it asks us for the coordinates of the points where it crosses the axes. So we need to find the coordinate where it crosses the y-axis. That's going to be quite straightforward. We can just substitute x equals 0 into the equation we were given. And then we need to find where it crosses the x-axis. And that's where we'll let the equation equal 0 and solve it. So let's find where it crosses the y-axis to begin with. So if we go back up, we had y equals 2x squared minus 12x plus 1. We're going to let x equal 0. So that's going to give us y equals 0 squared is 0 times 2 is 0. Take away 12 times 0, so take away 0 plus 1. So y is equal to 1. So it's going to be the coordinate 0, 1. So that point there, here, is the point 0, 1. And then we need to find where the quadratic crosses the x-axis. That means that our height will be equal to 0. We could let this equal 0, our 2x squared minus 12x plus 1 equals 0. Now it's a non-calculator question. If I was to let that equal 0, I would like to use the quadratic formula and get, let a equals 2, b equals negative 12, c equals 1, and use the quadratic formula to find the solutions there. But this is a non-calculator question, so I'm actually going to use the completing the square to help me. So we're going to let that equal 0. So let's write down y equals 2 bracket x minus 3 close bracket squared minus 17. And we're going to let that equal 0, and that will help us find the coordinates of where it crosses the x-axis. So that will be 2 bracket x minus 3 close bracket squared minus 17 equals 0. Let's add 17 to both sides of that equation. So we get 2 bracket x minus 3 close brackets squared. And then if we add 17 to both sides, you get equals 17. Divide both sides of the equation by 2, so we're going to get x minus 3, close bracket squared, equals 17 over 2. So that means that x minus 3 is equal to plus or minus the square root of 17 over 2. And then we just need to add 3 to both sides. That'd be x equals, and whenever I add 3 to both sides here, I need to put the 3 in front of the plus or minus, so I'm going to get 3 plus or minus the square root of 17 over 2. And that means we'll have two solutions, that either x equals 3 plus the square root of 17 over 2, or x equals 3 minus the square root of 17 over 2. So that means the point here would be the smaller one, the 3 minus root 17 over 2, and that's your x coordinate, 0. Coordinate here would be 3 plus the square root of 17 over 2, 0. And that's it. And that's it. So this quadratic graph, it would have a minimum point of 3, -17. It'll cross the y-axis at 0, 1. And it'll cross the x-axis at 3 minus the square root of 17 over 2, 0. And 3 plus the square root of 17 over 2, 0. And that's it. And that's it. So these have been the video solutions to the turning points used in completing the square practice questions. I really hope you found this video useful. If you need any extra help on this topic, if you go to video 265A on Corbettmaths, that'll be really useful. If you have found this video useful, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers, bye.